So thank you all for coming along today, and welcome to this session, which is all about carbon. So what is carbon and why don't we like it? A 101 guide to carbon neutral. So we've got Tim with us here today to give us a bit of a rundown on this topic. But before we do begin, I'd just like to first of all acknowledge the traditional owners of the land that we're on, the Bunurong people, and pay respect to elders past, present and emerging, and acknowledge that these lands were never ceded. Now, this event is being run as part of the Sustainability Festival, Reimagined, which is an online program, as you can see behind me. And we're really taking this opportunity, Totally Renewable Phillip Island, as a community group to explore some of the topics around issues that we may know about but may not know many details about. So that's why we've asked Tim to come along today and just give us a bit of a rundown on what carbon is and what All of Us is actually about. So without further ado, Tim, I will turn myself off and I'll hand over to you, and feel free to share your presentation. Thank you.
Okay, thank you, Zoe. And thanks everybody for joining us. I'm hoping that Zoe might keep an eye on the chat window. If anybody has any quick questions as we go along, you could maybe put them in the chat window, and if she could alert me to a question along the way that might be pertaining to the slide that we are presently on, that would be wonderful. Zoe did mention that I'm presenting about carbon. I'm going to give you the science teacher version of what I know about carbon, because before I do that, I'll just announce who I am and what gives me the qualifications to talk about carbon. Okay, so who am I? So I've been a resident on Phillip Island since 1993. If you ask my mother, she'll let you know I've always nagged her about environmental causes ever since childhood. I can't remember when that started, but I do remember always being environmentally conscious from an early age. I have a Bachelor of Science that I attained in 1992, majoring in aquatic science. I wanted to do marine biology, but I didn't quite have the guts in my early time to go all the way up to Townsville to enroll in the marine biology course. But I did aquatic science, which is mostly freshwater, and also the other major was statistics. So that's my interest in data, and probably what's drawn me to this carbon accounting working group. Currently, I'm a maths teacher and science teacher. Also, geography is one of my other methods, and currently teaching at Cooley Secondary College. So I've been here 12 years, 13 years coming on. Okay, without too much further ado, what is carbon? So we mentioned in the heading that we don't like carbon. Well, we actually love carbon because it actually is what we're all made of. So the slide you're seeing now is the little tile from the actual table of elements. So carbon is one of the, in its pure form, is element number 6. The 6 indicates how many protons it has in its nucleus, and it has 6 electrons in its outer shells. But that's if it's a stable element. A stable atom of carbon has 6 protons and 6 electrons, balancing out the electrostatic forces. The number you see on the bottom there, the 12, is 12.011. Carbon and various other elements can exist with differing numbers of neutrons that combine with the protons in the nucleus. So the 12 is called the mass number, and it's like an average of the masses according to abundance of all the 3 carbon types of isotopes. So there's carbon 12, carbon 13 and carbon 14. So you might have heard of carbon 14. They actually use that for dating old rocks and old samples that have carbon in them. It's a radioactive isotope of carbon, and it breaks down over time. And that's how they know how old it is, basically. So carbon is actually a really likable element. It exists on Earth in two main forms: a crystalline form, which you might have seen. Someone might have a diamond ring on their fingers. Someone might have used a pencil that has graphite in it, and that's actually a crystalline form of carbon. And there's also other forms called fullerenes, buckyballs. I'm not sure you might have heard of buckyballs in the past, but they're the crystalline forms. Amorphous basically means no formal shape to the material, and charcoal and black coal and coke are forms of amorphous carbon. All right, so how much of carbon is in the Earth? So in Earth, carbon actually sits, it's not listed in any of these, it's actually in all the others. So in the Earth's crust, there's not a lot of carbon compared to other elements. The big one is oxygen, and silicon is the other one. So in the Earth's crust, it's typically not really known as an inorganic element. In life, though, carbon represents about 25 to 30% of all of the elements that make up life on Earth. So that's what I meant before about being a very likable element. Without it, we wouldn't exist as human beings, and most of the animals and plants and even bacteria on Earth wouldn't exist without carbon. In the universe, though, hydrogen is the most common because that makes up all the stars, and helium, hydrogen fuse together to become helium, and then helium fuse together to become carbon eventually. And yeah, that's where the carbon comes from, comes from stars. I'll just move this out of the way. In the crust itself, the carbon is mostly in 2,700 parts per million in the crust. We don't know how much is in the other parts because it's mostly molten material in there. In the atmosphere, we're up to about approximately 400 parts per million. So, and that's up from 270 to 280 over 1,000 years ago. In the seawater, it also dissolves into seawater in about 30 parts per million. Okay, so some common examples of carbon loves to actually bond with other elements. Because it has 4 electrons in its outer shell, it likes, most atoms and elements like to have 8 electrons in their outer shell. So they can either share the 4 electrons they have with other elements and form very strong bonds, or sometimes not so strong bonds. And they also form very, very long molecules that make up things like proteins, carbohydrates, lipids, which are like fat molecules in our body, and they're even in the sugars that make up the rungs of, so not the rungs, but the actual ladder sides of DNA. So everyone hopefully has heard of DNA, the building blocks of life itself. And yeah, so carbon is in everything. It's also in a lot of other elements, and here's some examples here with really long names. And I won't go too much into that. If you want to go into organic chemistry, I have a huge textbook about that thick on my shelf that teaches everything about organic chemistry. It's very complicated, but carbon is the basic element of all organic chemistry. So yeah, it's the basis of life. But what we love to do with carbon because we discovered quite before the steam age that hydrocarbons have a very, when we burn them and react them with oxygen, they produce lots of heat and lots of light. So lots of energy is released from burning of hydrocarbons. So any hydrocarbon, it's got an X and a Y there because there's various different types. Methane is CH4, so one carbon atom with 4 hydrogen atoms. But the product of burning them is always water and carbon dioxide. And carbon dioxide is a gas, and that will be released if we burn it in the air, which we have to because that's where the oxygen is. It will be released into the air, and that is what is unfortunately causing a problem with global warming. And I messed up the order of my slides. It's in the next slide. But carbon does cycle through on Earth. We have two natural formulas, which are actually the antithesis of each other. So cell respiration, which is what you and I are doing right now. All our cells in our body are burning sugars, glucose, with oxygen that we breathe in, and we breathe out carbon dioxide, and also some water vapor, and we produce some energy. So that's what all our cells are doing, how we can run around and move and grow and everything. The opposite reaction to that is photosynthesis, and that's what all the plants are doing on Earth. So most plants that you see, and also phytoplankton, which are plants that are floating in the ocean, little tiny ones, do this reaction called photosynthesis. So they need energy from the sun and light, and they take carbon dioxide combined with water, and they produce glucose, and you can see the carbons in there. So lots of carbons in the glucose formula, and plus oxygen. So the plants release oxygen to the air. So we, as human beings and animals, release carbon dioxide through our natural processes of life, and plants take carbon dioxide out of the air and make it into wood and glucose and all the structures of a plant. And hopefully what they do is when the leaves are the photosynthetic part of the organism, and then when they're making the actual rest of the plant, hopefully a lot of it goes down into the weeds, and that's what Bhavani will probably talk to you more about in the next slideshow. And Bob Davey is also doing some fantastic work with fixing more carbon back into the soil. So I won't go too much into that now. But as I said before, the carbon that we release as carbon dioxide into the air is contributing to what we call the greenhouse effect, and it is global in scale. Basically, the carbon dioxide is forming a blanket over our Earth. So the sunlight that comes in falls upon the Earth, and most of the radiation from the sun is bounced back off the Earth, and a lot of it goes back out to space. But the carbon dioxide, too much of it in the air will trap too much of that heat, and that's what's happening at the moment. It's not only carbon dioxide, but water vapor, methane, and other greenhouse gases are trapping too much of the heat. If we didn't have any carbon dioxide in the atmosphere, the Earth would be very, very cold. It would be average about 0 or minus 15 degrees Celsius. But with a good layer of CO2 in the atmosphere and other greenhouse gases, we should be living at a comfortable 15 degrees Celsius. But too much is unfortunately warming up the planet, and we started to notice this in the late 70s and 80s. A striking relationship between the grey line here is concentration of carbon dioxide in the Earth's atmosphere, and global temperatures worldwide. So global temperatures, the scale here is starting from 0. That doesn't mean 0 temperature, it just means the average temperature from the mid 20th century and so it's we're at 1.2, just below 1.2 degrees above that average. And that's what they're all talking about on the news and that when they're saying, we want to try and keep it below 1.5, because if we get up to 2, that has some quite disastrous effects on the global climate, can cause more melting of the ice caps and sea level rise. So that's what they're talking about there. And you can see the concentrations of carbon dioxide in parts per million as measured by many weather stations around the globe. Okay, so if we could see unfortunately carbon dioxide is a transparent gas and you can't smell it and you can't hear it obviously, but these screenshots here are from a Sustainability Victoria ad campaign that tried to get us to visualise the amount of CO2 that might be in the air from lots of our appliances burning electricity and or burning carbon, hydrocarbons, and yeah. So if we could see it, I think we'd probably be a lot more aware a lot earlier, and nobody would like to have black balloons floating around. But the problem is we can't see it, so we have to rely on scientists to measure the carbon dioxide and also measure the corresponding temperature rises. And yeah, most scientists, in fact, more than 97% of climate scientists do think that carbon dioxide is causing the rising temperatures that we're seeing. Interestingly, I often see in the literature when people are talking about emissions and reducing emissions, I heard this term carbon dioxide equivalent with a little E next to it. And basically what it is just comparing other gases like methane, nitrous oxide, those ones don't even have carbon in them, but this is a small table, but it just compares the actual the global warming potential of the other elements. So methane is actually quite about 72 times more potent as a potential warmer of the globe than carbon dioxide, but it doesn't last as long as carbon dioxide. It's probably not quite as clear in this picture. So that kind of helps us out there. But the big one in here is the sulfur hexafluoride, which is 22,000 times the global warming potential of carbon dioxide. And I learned recently that they use that to put in tennis balls. So it's a bit concerning. All right. Any questions so far?
Got a good comment from Bob. Glad you cleared up that carbon is good, Tim. A lot easier to grow and sequester carbon than learning the science.
Yeah, it is actually, can be quite complicated. And yeah, hopefully we will get to a stage that we may not have to necessarily understand the science, but we can appreciate the importance of trying to reduce emissions because yeah, the scientists do quite a lot of work to get all that information for us, and yeah, it's not as easy as what people think. So this carbon sequestration, so that's probably a good segue, thank you, Bob, into this slide here. So just talks about how carbon actually comes out of the air. So there's various ways. Plants, we talked about photosynthesis, and then they will pass it down into the soil, and Bob will talk more about that, and Bhavani will too. And the concentrations that carbon dioxide also gets absorbed into the ocean, and the phytoplankton in the ocean, which are basically plants, they photosynthesize, and they will take up some of the carbon dioxide. Once they die, they'll fall to the bottom of the ocean and hopefully stay there. So the long story short of that is that carbon in the air is bad. Carbon in the ground is better for us. We need some carbon in the air, but we don't want too much of it in there. The other problem with carbon too much carbon being absorbed into the sea is that it can acidify the ocean water, and it's having a bit of an effect on animals in the ocean that produce shells. What happens when calcium carbonate, which makes up the shells of gastropods in the ocean, the acid will eat away at the shells and produce hydrogen gas. So that is not a great outcome for gastropods. If we have too acidic oceans, and they become too acidic, then we wouldn't like to swim in them either. 0.7% of the world's forests are coastal mangroves, but they store up to about 10 times as much carbon per hectare as tropical forests. So the coastal reserves of vegetation are probably, as important, if not more important, than some of our forested areas. So yeah, blue carbon is a very important thing by trying to get it out of the air. I looked up what net zero means, and there are three terms I sort of experienced a lot over the last few months once getting into this position. But carbon neutrality is just talking about carbon emissions itself and trying to achieve a balance between the amount of carbon that is emitted into the air, and if you can't reduce them to zero, then trying to balance that out with removals by carbon sequestration. Net zero emission is actually talking about getting emissions down to zero as much as possible, but also making up any shortfalls. But and also talking about other greenhouse gases as well, not just carbon. Climate neutrality is a term we would relate to trying to eliminate all other negative environmental impacts that an organisation may occur. So this is what organisations can strive to achieve, and that's what we are as TRPI, Total Renewable Phillip Island, are trying to achieve carbon neutrality by 2030. Here's some of the best practices hierarchies. So typical carbon management hierarchies in businesses. The one at the top is what you should be doing more of, just like the food triangle. You should have more, try to be efficient as possible with using things that would produce carbon emissions like energy or transport, and then going down the triangle, on-site renewable energy, trying to put solar panels on your property buildings or wind generation. And then if you can't do that, build solar farm or buy renewables from a retailer. And then your last resort should be buying carbon offsets. So yeah, that's the hierarchy. Australia's got a plan. Hopefully you've heard about that plan, and I copied this from the government website. And one of the big things is clean hydrogen and ultra low cost solar, carbon capture and storage, which they're trying to get under $20 per tonne of CO2. But that's a developing technology. I don't think there's any carbon capture and storage that will scale up to the size that we need to cover our fossil fuel burning plants. So that's a future technology that they're trying to put money towards. And 2050 is probably getting on the late side. The Shire have Bass Coast Shire that Phillip Island belongs to are trying to reduce their, they're trying to get to net zero by 2030. So this is a link to the action plan, and this graphic here. Main thing I've got out of this is our emissions for 2019 were around about 600,000 tonnes of CO2. So what we're trying to do is get that down to zero. And if we didn't, because we know that we expect our council to grow in numbers by 2030, probably a bit more if we took no action, but hopefully we can take some action and get down to net zero by 2030. And here's a graphic that tells you where most of those 618,000 tonnes of CO2 are coming from, mostly buildings. So 267,000 tonnes, so that's a bit over a third. Transport, so agriculture and waste and wastewater, industrial processes, and then hopefully the negative going to land use and forestry in the area, trying to sequester carbon out of the air. Okay, here's some of the recommended actions for households. Now, they also have recommended actions for businesses, and they have recommended actions for council itself. But here's some recommended actions from the plan. So obviously buying less and of materials that are produced using carbon. So switch to all electric and zero carbon energy. Improve homes to make them sustainable and climate resilient. So Zoe should know all about that. She's done the course in sustainable housing. And trying to reduce the amount of transport you're using, ride sharing and electric vehicles. Planting more gardens, trying to reduce the increase the amount of vegetation growing to sequester more carbon out of the air. Buying local to reduce transport costs of food coming to your area, and supporting sustainable regenerative agriculture. That's Bhavani and Bob in our area. And there's a couple of other recommendations on there, but for all the full recommendations, have a look at the plan. I did notice this, ZNET stands for Zero Net organisations. So here's an approach that is in the plan that is suggesting we take as a community to try and get to net zero. And I won't go through all that, but it's fairly generic. The plan goes through in a lot more detail on how we could get to net zero by 2030. And last of all, I guess one of our leading up the carbon accounting group is I'm hoping to get a visualization on how do we know we're heading towards net zero. So there's going to be annual reviews of the Bass Coast Shire plan, and they're also trying to do a mid review in 2024. So that's 5 years, not 2019 to 2030. So 23, 24, they're planning to do a full, a bigger scale review of their 2030 net zero plan. I know Bob's doing a lot of testing, carbon testing in his soils. It would be good if that could be something that's, you know, more widely known, I guess, across the community, so that we could, you know, encourage others to get their soils tested. And if that was an easier process, I guess that would be a greater incentive for people to be trying to increase the level of carbon in their soil. It'd be good to the plan from the council, actually, they suggested that there would be a community portal or an action tracker. So that's yet to be developed. So I'm hoping to work towards with other people in the carbon accounting group towards developing some sort of community online portal, and hopefully that could be advertised across the community in the various newsletters, newspapers, even on the sign at the Western Port Water site. So it's a great visual for people coming to our community. They could see how we're tracking towards becoming a net zero community. And it'd be great if you could have an app. I mean, you can actually have people, you know, control their house from their mobile phone these days. So it would be fantastic to just have it all in one place on one app, and have encouragement for people to take up excess solar when it's being used. Yeah, and hopefully that would be on the personal side, but hopefully we can develop better industry standards so businesses could, you know how they're tracking towards getting to net zero by 2030. And I put in some references into the thing. Zoe, where would you like me to actually, I'll have to ask you where we're going to put this presentation.
Not to put me on the spot or anything, Tim, but
No.
I think we'll definitely,
later, if anyone has any
questions. We'll make sure everyone on this call in particular receives a copy via email, but we will find a good accessible location, possibly the TRPI website, to store this information as well.
Okay, well, hopefully did I put you to sleep, Bob or Bhavani?
Not at all. I actually learned quite a few things from you, Tim, which was really good, because I am no expert, even though I'm speaking on it.
No, cool. Thank you.
That was great, Tim. Very good. I'm learning more every day about the science of it.
Yeah.
I can pull down the CO2 and I can turn it into carbon, But I think you're right about a lot of farmers need to be tested to establish how many thousands of tonnes of carbon they've actually got in their soils. That could be put against, the emissions of the whole Shire. So if they increase that carbon, they can use it. If they don't increase it, they can use it to become carbon neutral anyway.
Yeah, I agree. How
Thank
many
you.
other farmers in our Shire are doing as much as what you're doing, Bob? Do you know?
Yeah, but I hope it all comes together. I think there was an announcement this morning by the government that they're going to assist in a pretty big way with carbon sequestration. So it'll be interesting to see what comes out of that.
Yeah, it was big in their plan, wasn't it? Saying we've got a lot of land in Australia to store carbon in the soil.
Yep. Well,
and because our soil is so old compared to European soils, it is much lower in carbon. So it'd be really good actually to do that for our own benefit.
Yeah.
Yeah.
A lot of it's eroded away, I'm guessing, being such an old continent.
Mm.
And the interesting part will be as to how much carbon we can sequester per hectare. So that's a challenge for everybody through Gippsland, just to see how high it can go. The vet museum just did testing, and they've got pretty high readings down there at New Haven on virtually a saline area. So if different areas of the island were tested, well, then we'd have an idea of how much we can put against the emissions. And I'm sort of thinking nature parks, ovals, a lot of things. But anyway, we'll see what happens. Thanks, Tim.
Sorry, Bob, I was just plugging my computer in, otherwise I would have died.
And that Anna made a comment in the chat, which I think is really relevant, that she said, good to get some facts. She's concerned but not informed. And I think that's a huge problem, is the lack of, for everyone, the lack of where they're getting the information and whether that's trustworthy or correct. And yeah, just having some basic information. So it's a good comment, Anna.
Yeah, and Anna, it's always a good idea. That's why I did include the references there. I probably haven't referenced all of my visuals. However, it gives you a bit of a jumping point off to go and, I always, basic rule of thumb I tell my students is if you're getting the same information from, at least 3 sources and they're reputable sources, in other words, they're the government or educational or regulated sources. Then
You mean not Facebook?
Yeah, well, no, unless it's a government Facebook site, but that would direct you to a different one as well. Yeah, it's in the age of fake news and everything. It is important to make sure you've got those facts, down pat.
I've got a bit of a question, and it's kind of a mild epiphany for me, I guess, in terms of being slightly provocative with the title of this session. But there is this perception that carbon is a bad thing. So I think it's really interesting to think that it's not necessarily bad. It's just more about balance and being aware of the ups and downs, which I guess is balance.
Yeah.
But just understanding some of that chemistry of it and how it actually is part of an integrated sort of ecological system as well. It's quite fascinating.
Well, the balance of having the photosynthesis and respiration, they're exactly the same, backwards, back to front. So nature, I guess, balances those things. And we've also got to stop thinking about humans as being separate from nature. We actually are a part of the world, we're part of the ecology. I think there's always been this thought in environmental science of humans being separate, you know, that's nature and this is humanity, but we're not. We're part of the same process. But I believe we're clever enough. I believe we're clever enough to work out, and yeah, that's what I'll be aiming towards anyway.
I know you probably have to dash off soon, Tim, but I was curious. I know you've done a little bit of work with trying to improve or grow mangroves. You've been involved in some projects of that nature.
Yeah, there's been a couple of projects in Western Port. Mostly they're concerned with reducing erosion on coastal areas. So less to try and draw down, less focus on drawing down carbon. But yeah, there is some great work in, and I can't remember the guy's name, who was doing some work in Western Port for trying to develop blue carbon. It might be with CSIRO, so I might get back to you on that and put it in.
I should have warned you I was going to ask you about it.
No, that's right. We have discussed it before, and it was with you or somebody else recently, so I should remember it.
I know locally down at Yarram, their land care network area is working on doing a lot of seedgrass planting.
Yes.
Not mangroves, but getting the seedgrass going again.
Yeah. Yeah, there's a lot of erosion along in the Western Port Coast, especially Coronella and on the island as well.
Very good. Well, I guess, are there any other questions from anyone who has not asked anything as yet, or shall we let Tim off the hook? Speak now, forever hold your peace.
I think the person with the mangroves was Tim Healy. Tim Healy that did all the mangroves. Yeah.
Yep. Thanks, Bob.
Yep.
Okay,
thanks. Thanks, everybody.
Thank you.
It was really good.
Very good. And I'll just mention...
I love your background, Zoe.
Oh, thanks.
I need to learn how to do a proper background like that.
Well, you know who to talk to.
Yeah, Zoe.
I was going to say Jenny.
Okay.
I will just put a little plug in. We'll say farewell now, but Bhavani is up in about half an hour to talk about regenerative carbon farming. So if you jump onto the TRPI Eventbrite page, if you haven't got the meeting link, or you can shoot me an email directly and I'll send you the link. But that will be a very interesting presentation as well. Fantastic.
I'm looking forward to that, Bhavani.
Oh, that's good. You and me too, Bob.
Okay.
Brilliant. Well,
Good
thank you
on
everyone for coming today, and thanks, Tim, for your time. And this recording will eventually make its way to the TRPI YouTube channel, so you can refer back to it for more technical details, shall we say. Great. Thanks, everyone.
Thank you.
Thank you.
Thanks, Tim. It was great.